Hello, welcome to the video lesson video notes for lesson 3-10, comparing expressions and exponents day 1. The learning target for this is I can write expressions with exponents in equivalent forms. So, we will be taking our knowledge of exponents and trying to apply it to what we have, the examples, and then coming up with equivalent forms or something that is basically the same. All right, so let's write that down because that's kind of a big idea. We all know what equivalent means, but these are the same value. That's what we're talking about. Alright, so, and this gets a little tricky sometimes to be able to think of what we might be able to do with this. So, we'll take a look at some examples. And this is on page 45 if I haven't mentioned it already. Page 46, we'll have some examples for us to do also. So, write as many expressions as you can that are equivalent to 3 to the 5th power. Now, when I think of 3 to the 5th, I think of 3 squared times 3 to the 3rd. Because if I have that, what I'm really doing is 3 to the 2 plus 3. And what does that equal? 3 to the 5th. Another example would be 3 to the 10th over 3 to the 5th. Why? Because if I have this situation, then really I'm dealing with 3 to the 10 minus 5, because remember the rule of exponents, same base, subtract the exponents, 10 minus 5 is 5. Or, another example might be 3 to the 1st. Now you might say, oh, 3 to the 1st times 3 to the 1st times 3 to the 1st. Okay, but another way to write that would be 3 to the 1st raised to the 5th power. Because what this really means is 3 to the 1 times 5, or 3 to the 5th. So, what I'd like you to do is to come up with 2 more examples on your own. And I'll talk about that after I do the next example with the variable, because if you do all of the ones with the star, then I will give you points on your scoreboard for it. So I'm going to clear the screen, so pause it if you need to finish copying. And the next example on page 45, again, write as many expressions as you can that are equivalent to x to the 9th. Alright, so let's try x to the 6th times x squared times x to the 1st. Because really what that means is x to the 6th plus 2 plus 1. Now if you didn't want to put the 1 there, you don't need to. Because remember, if there isn't an exponent, you treat it like a 1. 6 plus 2 plus 1 is 9, so x to the 9th. Or another example might be x to the 15th over x to the 6th. When you have a fraction or when you're dividing, same base, you subtract the exponents. And then the last example I'll give you, raising a power to a power, x to the 3rd. So, if I'm going to raise that to a power and get x to the 9th, what do I do? Raise it to the... It is not 3 plus 3. When you raise a power to a power, that is going to be the exponents multiplied. Again, just like up above, do 2 more examples. And if you try all 4, then you'll get a point on your scoreboard just for trying. Then I might ask you to share them and we might even earn some more. All right, over on the next page, page 46, we have some more examples to take a look at. Now, watch what happens here because there's some interesting ones. We're looking for the ones that are equivalent to 2 to the 4th. All right? Now, one way to test this, 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So, in the end, it has to be equivalent to 16. But we can use the rules of exponents to get us there faster, I think. So, 2 to the 4th times 2 to the 0. That's 2 to the 4 plus 0, and 4 plus 0 is 4. So, 2 to the 4th, this one works. 4 squared. Now, some of you might be saying, wait a second, what is that? Well, remember, 4 squared is 16, and that's what we're looking for. But I want to show you this another way. 4 is the same as 2 to the 2nd power. And we're raising that to the 2nd power. So 2 to the 2nd raised to the 2nd is 2 to the 2 times 2, or 2 to the 4th power. This one works. 2 to the negative 7 times 2 to the 11. So, since we're multiplying, same base, add the exponents. Negative 7 plus 11, 2 to the 4th. This one works. 2 to the 5th over 2. Well, that's the same as 2 to the 5th minus 1, which is 2 to the 4th. This one works. Oh, look at that. That's the same as the second example that we did earlier. Multiply those, you get 2 to the 4th. And then this one, watch out. Some people might think that this one is definitely not going to work, but watch what happens. So we're doing division, so we subtract 2 minus negative 2. Well, when you subtract a negative, you add, and when you add, you get 2 to the 4th. So, which expressions are equivalent? All of them. Okay, so now we have some examples below, which are equivalent to 1/9. 3 to the negative 2. Oh, by the way, 1/9 is the same as 1 over 3 squared, or 3 to the negative 2 power. So watch what happens. Well, our first example we already know is going to work, 3 to the negative 2. But let's just convert it to make sure. We don't like negative exponents, so it's really 1 over 3 squared, or 1/9. So this one works. 9 squared over 9 cubed. Well, that's the same as 9 to the 2 minus 3, which is the same as 9 to the negative 1, which is the same as 1/9. This one works. 9 times 9 to the 0. That's the same as 9 to the 1 minus 0. But 1 minus 0 is 1. This one does not work. 3 squared raised to the negative 1 power. That's like 3 squared times negative 1. 2 times negative 1 is negative 2. We already know this one is going to work because we did that in the first example, 1/9. And then the last one, 3 to the 5th over 3 to the 7th. Same thing. 5 minus 7 is negative 2. And we know 3 to the negative 2 will work. Alright, 1/9. And so all of them but the middle one works for the second one. Alright, that's it for this lesson. Nice and short. If you had any trouble, go back and rewatch the video or come and see me for help. Good luck, and we'll see you in math.